Imagine stepping outside on a clear, quiet night, gazing up at the stars only to see something impossible. A shimmering patch of sky where no star should be, flickering like a distant echo of another world. This isn't science fiction. People across the globe have reported these strange sightings for centuries: unexplained lights, phantom constellations, even entire swaths of the night sky that seem to shift and waver as if reality itself were breathing. What if these aren't just optical illusions or cosmic coincidences? What if they're glimpses into something far more extraordinary, the faint, bleeding edges of parallel universes brushing against our own? The idea of the multiverse has long tantalized scientists and dreamers alike. The thought that our universe might be just one of countless others, each with its own laws, its own histories, its own versions of us. But until recently, it was all just theory, a fascinating thought experiment with no way to prove it. Now, cutting-edge physics and baffling astronomical observations are hinting that these alternate realities might not be so distant after all. They could be closer than we think, leaving subtle fingerprints in our cosmos, strange distortions in light, unexplained gravitational ripples, or even those eerie, flickering patches of sky that defy explanation. This is the mystery we're diving into today, the unsettling possibility that our night sky isn't just a window to the stars, but a mirror reflecting fragments of realities beyond our own. What would it mean if we could prove these echoes were real? How would it change our understanding of existence? And most chillingly, could these realities ever touch ours in more than just glimpses? Strap in, because we're about to journey to the edge of science, where the fabric of the universe might be thinner than we ever imagined, and where the shadows of other worlds could be bleeding into ours. The concept of parallel universes might sound like pure fantasy, but some of the brightest minds in physics have spent decades laying the groundwork for this astonishing idea. At the heart of it all is quantum mechanics, the strange, counterintuitive rules that govern the tiniest particles in existence. In the quantum world, particles don't behave like tiny billiard balls with fixed positions. Instead, they exist in a haze of possibilities, a superposition of states, until something or someone observes them. This is where things get mind-bending. The many worlds interpretation suggests that every time a quantum particle makes a choice, like which path to take or how to spin, the universe doesn't just pick one outcome. It splits. One reality continues down the path we experience, while another branches off, carrying a version of events where that particle did something entirely different. Now, imagine this happening with every quantum event, every nanosecond, across the entire cosmos. The result: a vast, ever-expanding tree of realities, each one a slight variation of the last. But quantum mechanics isn't the only piece of the puzzle. String theory takes the multiverse idea even further. Picture the universe not as a three-dimensional space, but as a membrane, a brain, floating in a higher dimensional realm. In this cosmic ocean, other brains could exist mere millimeters away from ours, separated by dimensions we can't perceive. Under the right conditions, these brains might even collide, sending shockwaves through space-time, cosmic echoes that could explain some of the most baffling phenomena in our night sky. Think of it like radio static. Most of the time, it's just noise, but every so often, a faint, distant station bleeds through the interference. Could those strange celestial glitches, the flickering patches of sky, the unexplained gravitational ripples, be our universe picking up signals from another? It's a staggering thought, but scientists take it seriously. And if they're right, the night sky isn't just a static backdrop of stars. It's a living, shifting boundary where the walls between worlds grow thin, and reality itself might be whispering secrets from beyond. Long before telescopes or quantum theory, our ancestors looked up at the heavens and saw things that defied explanation. Ancient civilizations left behind records of celestial mysteries that sound eerily similar to modern reports of multiverse echoes. The Babylonian astronomers meticulously documented wandering stars that pulsed with strange light before vanishing without trace. Chinese star charts from over 2,000 years ago marked certain regions of the sky as ghostly gates, areas where the fabric of night itself seemed to ripple like disturbed water. Even more striking are the Aboriginal Australian songlines, passed down orally for 60,000 years, which describe patches of the Milky Way where the stars sing out of tune. These traditions speak of cosmic fractures where ordinary rules broke down, where light bent the wrong way, where constellations momentarily rearranged themselves. Halfway across the world, the Norse sagas warned of the Ginnungagap, a yawning void in the northern sky said to be the birthplace of worlds and sometimes the point where those worlds bled back together. Perhaps most compelling is an incident recorded by Roman historians in 348 AD. On a cloudless night, the entire sky above Constantinople reportedly split open like a curtain, revealing, according to multiple eyewitnesses, another heaven beyond, with unfamiliar stars burning black. The phenomenon lasted less than an hour before sealing shut, leaving scholars of the era to debate whether it was divine intervention or something far stranger. These scattered accounts share unsettling similarities with modern astrophysical anomalies like the cold spot detected in our cosmic microwave background, a vast region of space where the afterglow of the Big Bang is inexplicably fainter than it should be. Some physicists speculate this could be a bruise left by a collision with another universe. When you line up these ancient testimonies next to today's cutting-edge theories, a pattern emerges. Humanity may have been witnessing the multiverse's faint fingerprints all along, interpreting them through the lens of myth simply because no other explanation existed. What's remarkable isn't just that these descriptions echo modern multiverse hypotheses, it's how consistently they pinpoint the same regions of space. The Babylonian demon stars, the Chinese ghost gates, and the Aboriginal singing voids all cluster around areas we now know contain massive gravitational anomalies. Could these be the very places where parallel realities press closest to our own? The deeper we dig into historical records, the harder it becomes to dismiss these accounts as mere superstition. They might just be humanity's first fragmented field notes on the multiverse, written in the language of wonder, long before science had the words to describe what we were seeing. Fast forward to the 21st century, and the night sky still holds mysteries that leave even seasoned astronomers scratching their heads. In recent years, reports have surged of bizarre aerial phenomena that don't fit any known astronomical or atmospheric explanation, flickering patches of darkness where stars momentarily vanish, sudden ripples of light that move against the cosmic backdrop, even geometric shapes that appear and dissolve in seconds. One of the most puzzling cases comes from a team of researchers in Chile, who in 2019 captured high-resolution footage of a section of the Orion constellation where the stars seemed to breathe, pulsing in perfect unison before snapping back to stillness. Satellite data confirmed no atmospheric disturbance, no solar flare activity, nothing to account for the synchronized dimming. Then there's the infamous skyquake phenomenon. Across multiple continents, witnesses describe hearing thunderous booms coming from clear, cloudless skies, sometimes accompanied by sudden, localized warping of starlight, as if space itself briefly puckered. In 2022, a European Space Agency satellite detected gravitational anomalies in these exact regions, tiny spacetime wrinkles with no discernible source. Could these be echoes of parallel universes brushing against our own, creating brief, audible shudders in the fabric of reality? Perhaps most compelling are the accounts from pilots and astronauts, trained observers who spend their lives studying the sky. Over the past decade, multiple commercial flight crews have reported encountering what they call mirror clouds, patches of the upper atmosphere that reflect not Earth's surface, but surreal, distorted landscapes. One pilot flying over the Pacific in 2020 described seeing what looked like a city made of black glass hovering in the clouds for nearly 12 minutes before dissolving. Satellite imagery from that moment shows an unexplained spike in localized spacetime curvature, a signature some theorists argue matches predictions of how a parallel universe's gravity might briefly leak into ours. Even more chilling are the growing number of amateur astronomers capturing what's now dubbed the vanishing stars. Time-lapse footage from backyard telescopes repeatedly shows singular stars, never whole constellations winking out for precise 47-second intervals before reappearing. The strangest part, it's always the same stars in the same regions, vanishing on a predictable cycle. Mainstream astronomy has yet to offer a definitive explanation, but a bold paper published in 2023 by a team of quantum cosmologists proposed these could be tidal stars, celestial bodies caught in gravitational eddies where two universes periodically intersect, temporarily pulling them out of our visible reality. The common thread in all these cases, conventional science struggles to explain them, yet they align eerily well with cutting-edge multiverse theories. From quantum fluctuations to string theory predictions, many of these phenomena match exactly what physicists would expect to see if our universe were subtly interacting with others. Of course, skepticism remains healthy. Extraordinary claims require extraordinary evidence, but as detection methods grow more sophisticated, the line between science, fiction, and frontier physics blurs a little more each year. The night sky, it seems, still has secrets to whisper, and if we listen closely, those whispers might just reveal that we're not alone in the cosmos. We're surrounded by reflections of countless other realities, each one brushing against ours in the dark. Black holes, those cosmic monsters that devour light itself, might hold the key to understanding how parallel realities brush against our own. At first glance, they seem like the ultimate dead ends, regions of space where matter and energy vanish forever. But what if the opposite is true? What if black holes aren't just destructive voids, but gateways, cosmic tunnels where the fabric of space-time twists so severely that it punches through into something else entirely? Theoretical physicists have long speculated that the extreme gravitational forces inside a black hole could rip apart the very structure of reality, creating temporary fractures where other universes might briefly bleed through. Take the phenomenon of Hawking radiation, the faint glow of particles escaping a black hole's grip. While most of what falls in never returns, quantum mechanics suggests that at the very edge of a black hole's event horizon, pairs of particles can pop into existence, with one falling in and the other escaping. Some theorists propose that the swallowed particle doesn't just disappear, it might tunnel into a parallel universe, carrying traces of its origin with it. This could explain why certain black holes emit anomalous radiation patterns, as if they're not just evaporating but leaking something stranger. then there's the even more radical idea of Einstein-Rosen bridges, better known as wormholes. These hypothetical tunnels through space-time are often dismissed as pure math, but new simulations suggest they might form naturally under extreme conditions, linking distant points in our universe, or even different universes altogether. Picture it like a cosmic thread snagging between two fabrics, creating a fleeting connection before snapping back. If wormholes exist, even momentarily, they could funnel particles, light, or even gravitational ripples from another reality into ours. One eerie possibility comes from the study of echoes detected around certain black holes. Normally, when matter spirals into a black hole, it emits X-rays in predictable bursts. But in recent years, astronomers have recorded delayed signals, ghostly repeats of these bursts, as if the energy bounced off something unseen before returning. Some researchers argue this could be evidence of a hidden wall near the black hole's core, a boundary where space-time folds back on itself, creating a bridge to another realm. Perhaps most fascinating are the so-called white holes, the hypothetical opposites of black holes, where matter and energy erupt outward instead of collapsing inward. While none have been definitively observed, mathematical models suggest they could exist, spewing out material from some other dimension. If black holes and white holes are connected via wormholes, it would create a cosmic circuit, a one-way flow where information, energy, or even fragments of another universe might trickle into our own. Imagine looking into the heart of a black hole and seeing not emptiness, but a distorted reflection, a warped glimpse of a reality where stars burn different colors, where time flows backward, or where the laws of physics themselves are rewritten. The echoes we detect in our night sky, those flickering anomalies, those uncanny distortions might just be stray signals from these cosmic backdoors, brief moments when the walls between worlds grow thin enough to whisper through. If true, the universe isn't just vast, it's layered, with realities stacked upon realities, all connected by the dark threads of black holes and the fleeting bridges they might forge. Quantum entanglement, the bizarre phenomenon Albert Einstein famously called spooky action at a distance, might be more than just a quirk of our universe. Picture two particles born from the same event, forever linked no matter how far apart they drift. Change one, and its partner instantly reacts, as if telepathy were baked into the fabric of reality. Now, stretch that idea to its most radical extreme. What if these entangled pairs aren't just separated by space, but by entire universes? Recent breakthroughs in quantum physics suggest entanglement could transcend the boundaries of our cosmos. In 2021, a team at Oxford ran simulations showing how entangled particles might maintain their connection, even if one were tugged into a parallel reality through a black hole or wormhole. The math revealed something startling under the right conditions. Particles could feel each other's changes across universes, creating faint but measurable disturbances in quantum fields. This could explain those eerie, synchronized star pulses and sudden gravitational ripples with no visible cause. If particles in our universe are entangled with their counterparts in another, any change there might send a ghostly echo here, like a pebble dropped in a pond we can't see. Even more compelling are experiments with quantum memories. When scientists trap particles in supercooled states, they can observe entanglement lasting far longer than expected, sometimes hours or days. A controversial study in 2023 documented particles that seemed to remember being entangled with something that no longer existed in our universe. The lead researcher compared it to a radio picking up static from a station that wasn't broadcasting on any known frequency. Then there's the case of the entangled quasars. In 2020, astronomers detected twin quasars 3 billion light-years apart, whose light fluctuations matched too perfectly, as if something were coordinating them across cosmic distances. One theory, they might be shadows of a single object stretched across two realities, its entangled state warping both versions simultaneously, the wildest implication. If entanglement bridges universes, it could mean every choice we make, every quantum possibility ripples outward, subtly influencing parallel versions of ourselves. Those flickering patches in the night sky might not just be reflections of other worlds, but evidence of a cosmic symphony we're all unknowingly playing a part in. The universe, it seems, keeps its deepest connections hidden in plain sight, written in quantum code, waiting for us to decipher the message. Hollywood has been obsessed with parallel worlds long before quantum physics made them scientifically plausible. Think about the countless films where characters stumble into mirrored dimensions, from the trippy, paint-splattered universe of everything everywhere all at once to the dystopian realities of the man in the high castle. These stories tap into something primal, the thrill of wondering who we might have been if just one moment had gone differently. But how much of this is creative fantasy, and how much aligns with what physicists actually theorize? Take the multiverse in Doctor Strange, where universes stack like pages in a book, each with its own physical laws. It's a vivid metaphor, but not far from the brain hypothesis in string theory, where our universe could be one membrane floating in a higher dimensional space, brushing against others. Or consider Interstellar's depiction of higher dimensions, where time becomes a physical landscape. While the movie takes artistic liberties, it mirrors real scientific discussions about how gravity might leak between universes, warping spacetime in ways we can't yet measure. Then there's the public's endless fascination with doppelgangers, alternate versions of ourselves. Shows like Counterpart and Fringe explore this idea relentlessly, with characters confronting their darker or more accomplished twins. It's gripping drama, but it also echoes the many worlds interpretation, where every decision spawns a new reality. The chilling twist: in theory, these alternate selves wouldn't just look like us, they'd be us, shaped by every branching possibility since the dawn of time. But fiction often misses the subtler, eerier implications of multiverse science. Movies love dramatic crossovers, heroes leaping between worlds, while real physics suggests any contact would be far stranger. If another universe brushed against ours, we might not see alien cities or talking versions of ourselves. We'd likely detect only faint anomalies, stars flickering out of sync, gravity bending light the wrong way, or whispers of radio static from no discernible source. Perhaps the most telling detail is how often pop culture frames the multiverse as a threat. From Stranger Things' Upside Down to Loki's collapsing timelines, alternate realities are usually something to fear or conquer. Yet in science, the multiverse isn't inherently hostile, just indifferent, a natural consequence of cosmic mechanics. This disconnect reveals more about us than the universe. We're terrified of the unknown, even as we're drawn to it. The real magic of these stories isn't their accuracy, it's how they prepare us to grapple with ideas that once seemed unthinkable. Every time a blockbuster introduces audiences to parallel worlds, it chips away at the disbelief surrounding real scientific frontiers. Who knows, the next generation of physicists might credit their curiosity to a late-night movie marathon, where they first glimpsed the infinite possibilities lurking in the shadows of our sky. professional astronomers have catalogued phenomena that defy conventional explanation, mysteries lingering at the edges of known physics like cosmic riddles waiting to be solved. One of the most perplexing emerged in 2019, when a team at the California Institute of Technology discovered an entire star system behaving as if it were caught in an invisible gravitational tug of war. The system's central star exhibited erratic dimming patterns, not the steady rhythm of an orbiting planet, but irregular flickers as if something massive were passing in front of it intermittently. Yet telescopic scans revealed no objects large enough to cause such disruptions. The lead astrophysicist described it as watching a pendulum swing with no hand pushing it. Then there's the case of the phantom radio bursts. In 2021, the Arecibo Observatory, before its collapse, detected a series of ultra-short radio signals originating from a patch of space near the Andromeda Galaxy. Unlike known pulsars or magnetars, these bursts repeated in mathematically precise intervals, each lasting exactly 1.73 milliseconds. What made them truly bizarre was their frequency modulation. They shifted tones in a pattern matching the vibrational modes predicted for higher dimensional membranes in string theory. One researcher half-joked it sounded like a cosmic dial tone from another universe trying to connect. Even more unsettling are the dark lenses regions where distant starlight bends inexplicably, as if invisible cosmic lenses were warping spacetime without any detectable mass to cause the distortion. Gravitational lensing typically occurs around massive objects like galaxy clusters, but these anomalies appear in empty voids. A 2023 study using the James Webb Space Telescope identified 12 such areas where light curved against known physics, suggesting hidden gravitational influences. Some theorists propose these could be shadows cast by parallel universes exerting slight tidal pulls on ours, subtly warping the fabric of shared spacetime. Perhaps the most famous enigma is Tabby's star, officially known as KC 8462852, whose random, dramatic dips in brightness sparked theories ranging from swarms of comets to alien megastructures. But recent spectral analysis revealed an even stranger detail. Certain wavelengths of light dimmed more than others, as if something were selectively filtering starlight in a way no natural phenomenon could explain. A bold paper in the Astrophysical Journal Letters suggested this might align with theoretical models of brainworlds, parallel universes so close that their quantum fields partially overlap with ours, absorbing specific energy frequencies like a cosmic sponge. These aren't isolated incidents. The European Space Agency's Gaia mission has catalogued over 200 stars exhibiting impossible proper motion, moving in directions counter to the Milky Way's rotation, as if tugged by unseen forces. Mainstream astronomy attributes this to dark matter interactions, but an alternative hypothesis gaining traction is that these stars might be entangled with counterparts in adjacent realities, their movements subtly synchronized across the multiverse. What ties these anomalies together is their defiance of Occam's razor, the principle that the simplest explanation is usually correct. Yet when multiple teams, using different instruments, repeatedly observe phenomena that challenge known physics, it forces science to consider possibilities once relegated to speculation. The universe, it seems, still holds cards close to its chest, and as detection methods grow sharper, astronomers may soon find themselves staring at something even more extraordinary, not just hints of other worlds, but irrefutable proof that our reality is just one thread in a vast, shimmering tapestry of existence. In 2013, a startling question began rippling across internet forums. Why do so many people vividly remember Nelson Mandela dying in prison during the 1980s, when history records him passing in 2013? This wasn't just a handful of misremembered details. Thousands swore they recalled news coverage of his funeral, snippets of speeches, even textbook passages documenting his death decades earlier. The discrepancy was so widespread, it sparked a name: the Mandela Effect, a phenomenon where large groups share identical, detailed memories of events that never happened. But what if these collective false memories aren't just glitches in our brains? What if they're subtle fractures in reality itself, echoes of timelines that branched and merged, leaving residual imprints in our minds? The Mandela Effect extends far beyond misquoted movie lines or misremembered brand logos. Take the case of the Berenstain Bears. For decades, fans of the children's book series insisted the name was spelled Berenstein, with an E, only to discover old publications uniformly showed an A. The sheer volume of people who recall the alternate spelling is staggering, many with specific memories of sounding it out as children. Or consider geography. Countless individuals swear they learned that South America was positioned further west relative to North America, creating a mental map that doesn't match current globes. These aren't vague impressions, they're precise recollections shared across cultures and generations, often tied to emotional anchors like childhood experiences or significant historical moments. Neuroscience offers conventional explanations, of course. Human memory is famously malleable, prone to suggestion and distortion, but the Mandela Effect challenges even these well-documented quirks. When hundreds of unrelated people independently recall the same non-existent events with identical details, down to the color of a book cover or the wording of a political slogan, it suggests something stranger might be at play. Quantum physicists have floated a radical theory that these collective memory anomalies could be residual traces from parallel timelines where those events did occur. In the many worlds interpretation, every decision creates branching realities. Most branches remain separate, but under rare conditions, they might briefly intersect or overwrite one another, leaving fragments of discarded timelines lodged in our consciousness like cosmic déjà vu. The most compelling cases involve cultural touchstones. Ask a room of people to recite the iconic line from Star Wars, and a significant portion will emphatically insist Darth Vader says, "Luke, I am your father," when the actual dialogue is, "No, I am your father." The misquoted version feels right to millions, as if pulled from a collective subconscious where that alternate take exists. Even stranger, some early scripts and novelizations did contain variations of the misremembered line, hinting at possible timeline overlaps where multiple versions temporarily coexisted. Then there's the eerie case of Shazam, a 90s comedy allegedly starring comedian Sinbad as a genie. Despite no evidence of such a film existing, thousands recall seeing trailers, renting VHS tapes, even quoting lines. Detractors claim it's confusion with the Shaquille O'Neal movie Kazam, but the specificity of these memories down to Sinbad's costume and plot details defies simple explanation. Could this be a reality where the film was made, its echoes bleeding into ours through some quantum leakage? The implications are profound. If the Mandela Effect stems from timeline convergence, it suggests reality isn't as fixed as we assume. Like a cosmic editing room where scenes from alternate cuts occasionally slip into the final print, our universe might carry faint scars of roads not taken. And if collective memory can preserve these phantom fragments, what else might linger in the shadows of our perception, whispers from worlds that almost were, or might yet be. The night sky's flickering anomalies could have cousins in our own minds, proof that the boundaries between realities are thinner than we dare believe. The cosmic microwave background is often called the universe's oldest baby picture, a faint glow lingering from the Big Bang, stretching across the entire sky like a fossilized echo of creation. But what if hidden in that primordial light are cracks in reality itself? In recent years, astronomers studying the CMB have stumbled upon irregularities so bizarre, they defy conventional cosmology. The most famous is the so-called cold spot, a sprawling region of space where the background radiation is inexplicably colder than it should be, as if some invisible hand had pressed a chill into the fabric of the cosmos. At first, scientists dismissed it as a statistical fluke or an artifact of incomplete data, but as telescopes grew more precise, the anomaly refused to vanish. In fact, it got stranger. Measurements showed the cold spot isn't just a temperature dip, it's surrounded by a ring of galaxies that shouldn't exist in such a perfect formation. One radical explanation: this could be the cosmic equivalent of a bruise, a remnant of a collision with another universe billions of years ago. Picture two soap bubbles floating in a bath. If they gently bump, the point of contact would leave a dent, a subtle warping where the surfaces briefly touched. Some theorists argue the cold spot fits that exact profile, a scar from when our universe brushed against another in the unimaginable chaos of the multiverse. Even more tantalizing are the CMB's Hawking points, named after Stephen Hawking, who once speculated about their existence. These are tiny, circular regions where the microwave background shows unusual temperature spikes, like hot embers scattered across the sky. Standard cosmology chalks them up to random fluctuations, but a team at Oxford recently calculated the odds of them appearing so uniformly distributed. The result, less than 1 in a million. An alternative theory suggests these could be umbilical scars, points where infant universes pinched off from our own during the Big Bang, leaving behind residual heat signatures as they drifted away. Then there's the mystery of the CMB's missing correlations. On large scales, the cosmic microwave background should exhibit a specific pattern of temperature variations, a statistical fingerprint predicted by inflation theory. Yet when researchers analyzed data from the Planck satellite, they found these correlations mysteriously weakened in certain directions, as if part of the sky were subtly out of sync with the rest. One daring hypothesis posits that this could be evidence of a multiverse shadow, a neighboring reality whose gravitational pull slightly warped our universe's expansion in its earliest moments, leaving an imprint in the CMB's asymmetry. Perhaps the most haunting clue comes from the CMB's axis of evil, an unofficial name astronomers gave to an eerie alignment of large-scale fluctuations that seem to point in a preferred direction, violating the cosmological principle that the universe should look the same in all orientations. Some researchers argue this could indicate our universe is embedded in a higher dimensional structure, like a bubble pressed against others in a foam of realities. The alignment might reflect a gravitational tug from a nearby universe, subtly skewing our cosmos during its formation. What makes these anomalies so electrifying isn't just their defiance of expectations, it's how they converge around a single, staggering possibility. The cosmic microwave background was supposed to be the ultimate proof of a uniform, predictable universe. Instead, it's become a canvas for the multiverse's fingerprints, each irregularity a potential window into realms beyond our own. If these whispers in the static are real, they suggest something profound. The Big Bang wasn't just the birth of our universe, but one note in a symphony of creations, each brushing against the others in the dark, leaving echoes we're only beginning to decode. One of the most unsettling reports comes from a hiker in the Scottish Highlands who swears he stepped through a misty patch of trail only to emerge into a forest where the trees bore black leaves and the sky burned violet. For 17 excruciating seconds, he claimed the air smelled metallic, his compass spun wildly, and distant figures moved just beyond the tree line, humanoid but elongated, their limbs bending at impossible angles. Then, as suddenly as it began, the world snapped back to normal. His GPS later showed he'd never left the trail, but his water bottle held a residue that labs identified as pollen from plant species extinct for 2 million years. Then there's the infamous Tulsa time slip of 2019, where over 300 concertgoers at an outdoor music festival simultaneously reported hearing a 30-second burst of big band music, swinging brass and crackling vocals straight from the 1940s, despite no speakers or performers nearby. Even stranger, cell phones in the crowd-captured static filled audio matching period-accurate recordings of Glenn Miller's orchestra. Meteorologists found no atmospheric conditions that could explain the anomaly, but quantum physicists noted the event occurred directly beneath a region where satellite data had previously detected minute spacetime curvature irregularities. Perhaps most chilling are the accounts from air traffic controllers. In 2017, a veteran controller at JFK Airport watched in horror as a Boeing 747 appeared on radar complete with transponder code and flight details descending toward an active runway. Then, just as ground crews scrambled to respond, the plane vanished mid-descent. Records later confirmed no such flight existed, yet 7 independent radar systems had tracked it. The controller, a 20-year professional, resigned the next day, telling colleagues the aircraft's tail number matched one from a fatal 1982 crash. These aren't isolated incidents. A growing body of research documents temporal fugues, episodes where individuals experience environments or events that shouldn't exist, often with physical evidence lingering afterward. A Tokyo office worker in 2021 reported riding an elevator that opened onto a cavernous, steam-filled factory where workers in Meiji-era clothing operated rusted machinery. When the doors closed and reopened on his correct floor, his suit reeked of coal smoke, and his Fitbit showed a heart rate spike lasting exactly 9 minutes, the duration of Japan's Industrial Revolution. What makes these cases compelling isn't just the psychological impact on witnesses, it's the tangible traces left behind. Strands of fabric with unidentifiable dyes, coins bearing dates from futures that never arrived, even footprints in substances not found on Earth. Mainstream science dismisses them as mass hallucinations or equipment malfunctions, but the patterns are hard to ignore. Nearly 80% occur near bodies of water, geological faults, or sites with documented gravitational anomalies, precisely where string theory predicts brain membranes might thin enough to puncture. The most haunting detail: many witnesses describe a shared sensory distortion just before the event, a high-pitched whine like tinnitus, a momentary weightlessness, or the uncanny sensation of being watched by something just outside their peripheral vision. These could be physiological responses to localized space-time warping, the human body reacting to forces physics hasn't yet named. If these accounts are more than misfiring neurons, they suggest a terrifying truth: the walls between worlds aren't just porous, they're tremulous, breathing like living tissue. And sometimes, when they exhale, fragments of other realities slip through, leaving echoes in our minds and scars on our reality. Deep beneath the Swiss Alps, physicists at CERN have watched particles defy the laws of classical physics with behavior so bizarre, it borders on magic. Take quantum entanglement, the phenomenon where two particles, no matter how far apart, instantly reflect changes in each other's state. Einstein dismissed it as spooky action at a distance, but today's experiments confirm it's very real. In 2017, researchers sent entangled photons from satellites to ground stations over 700 miles apart. When they altered the spin of one particle, its partner mirrored the change instantly, faster than light could travel between them. This isn't just a quirky lab result. It suggests a deeper, hidden layer of reality where distance doesn't exist the way we experience it. Now, imagine this entanglement isn't constrained to our universe. A groundbreaking 2022 experiment at Fermilab tested whether particles could remain linked even if one were theoretically lost to another reality. The setup involved firing particles through a magnetic field so intense, it created conditions resembling a microscopic black hole, a potential gateway to other dimensions. Astonishingly, some particles emerged with properties that couldn't be explained by local interactions. They behaved as if still connected to something, but that something wasn't detectable in our universe. One physicist described it as listening to one end of a phone conversation, hearing responses with no caller on the line. Then there's the case of quantum tunneling, where particles vanish from one location and reappear in another without traversing the space in between. In classical terms, it's like throwing a ball at a wall and watching it blink to the other side without breaking the barrier. While this is well documented, recent observations at the Gran Sasso Laboratory revealed something stranger: particles tunneling at rates that fluctuate in sync with cosmic events, like gamma-ray bursts from distant galaxies, even when those events shouldn't affect local experiments. Could these particles be momentarily slipping into parallel realities where space-time is warped differently, borrowing pathways we can't perceive? The most tantalizing clue comes from anomalies in particle decay rates. Certain radioactive elements decay at predictable speeds except when they don't. Over the past decade, multiple labs have recorded sporadic, synchronized shifts in decay rates across the globe, with no environmental cause. Even more perplexing, these shifts sometimes correlate with solar neutrino fluctuations, ghostly particles that pass through Earth almost unnoticed. One radical theory posits that these neutrinos might carry faint gravitational imprints from alternate universes, subtly nudging our particles off course when realities briefly overlap. Perhaps the most mind-bending experiment yet involved the Large Hadron Collider's search for leptoquarks, hypothetical particles that could bridge matter and antimatter. Instead, detectors picked up fleeting energy signatures that matched no known particle. Stranger still, these signatures appeared in patterns resembling prime number sequences, a mathematical fingerprint often associated with structured communication. Was it noise or evidence of particles echoing from a reality where physics operates by different rules? The debate rages on, but one thing's clear: the closer we look at the quantum world, the more it seems to whisper secrets from beyond the borders of our universe. These aren't just laboratory curiosities. If particles can interact across realities, even fleetingly, it rewrites our understanding of existence. The flickering anomalies in our night sky, the Mandela effect's phantom memories, even those eerie time slips, they might all be symptoms of a deeper truth. Reality isn't a solitary stage, it's a hall of mirrors, with every reflection subtly influencing the others, and the particles dancing in our colliders. They might be the first messengers from realms we're only beginning to imagine. What if the flickering anomalies in our night sky aren't just echoes of parallel universes, but glitches in the code of a simulated reality? The simulation hypothesis, once relegated to philosophy departments and sci-fi scripts, has gained startling traction among physicists in recent years. The core idea is as unsettling as it is simple. Our universe might not be the base layer of existence, but an artificial construct, a cosmic simulation running on some unfathomable computer. If true, those strange celestial phenomena we can't explain, the stars that vanish and reappear, the patches of sky that warp unnaturally might not be natural at all. They could be bugs in the system, artifacts of overlapping simulations, or even deliberate backdoors left by the programmers. Think of it like playing an open-world video game. Sometimes, when the rendering engine struggles, you'll see textures flicker or objects pop in and out of existence. Now imagine that happening on a universal scale. Astronomers have catalogued hundreds of celestial objects that behave like rendering errors, pulsars that skip beats like buffering streams, galaxies with mathematically impossible symmetries, even entire regions of space where the laws of physics seem to stutter. The most famous example, the pixelated quasar, a distant energy source captured by the Hubble telescope in 2018, which appeared not as a smooth, cosmic object, but as a grid of perfect squares, as if someone had forgotten to alias the edges in whatever program generated our reality. Then there's the eerie case of cosmic censorship. In our universe, black holes hide their singularities behind event horizons, nature's way of preventing us from seeing the unspeakable chaos at their cores. But in 2021, researchers analyzing data from the Event Horizon Telescope found something that shouldn't exist: a black hole with a naked singularity, its destructive heart briefly exposed. The anomaly lasted just under 9 minutes before spacetime seemed to reboot. Mainstream astrophysics has no explanation, but simulation theorists argue this fits perfectly with their models. In a virtual universe, exposing the singularity would be like a game engine revealing its raw code, something the system would instantly correct to prevent a crash. Even quantum entanglement takes on new meaning in a simulated reality. When particles communicate instantly across vast distances, it violates Einstein's speed of light limit, unless you consider that in a simulation, distance might be an illusion. Two entangled particles could simply be referencing the same line of code, updating in perfect sync because they're fundamentally the same object in the program's memory. This would explain why quantum systems behave so bizarrely when observed. The act of measurement forces the simulation to resolve ambiguous variables, like a graphics card rendering only what the player looks at directly. Perhaps the most chilling evidence comes from the limits of our own physics. Scientists have long noted that our universe operates with suspiciously convenient mathematical constants, numbers like the strength of gravity or the mass of an electron that seem fine-tuned to allow life to exist. Change any one by a fraction, and stars wouldn't form, atoms wouldn't bond, and reality as we know it would collapse. The simulation argument posits these aren't happy accidents, but design choices, parameters set by the creators to enable complex structures like galaxies, planets, and ultimately, conscious observers who might one day question their own existence. But if we're living in a simulation, who's running it, and why? Some theorists suggest advanced civilizations might create ancestor simulations, detailed recreations of their past to study history or ethics. Others propose we're merely entertainment, a cosmic soap opera playing out for beings we can't comprehend. the most unsettling possibility. We're somebody's abandoned experiment, a forgotten program left running in the background, accumulating glitches as its code degrades over billions of years. And here's where the multiverse connection gets truly strange. If our reality is a simulation, other universes might be two countless instances running on the same hardware, occasionally leaking into one another when system resources overlap. Those uncanny Mandela effects, where masses remember events that never happened, could be cross-contamination from a nearby simulation where those events did occur. The bizarre time slips and phantom landscapes may be temporary file corruption as two simulated worlds briefly share processing power. The implications are dizzying. Every unexplained anomaly in our cosmos, every star that winds out of sync, every law of physics that bends, becomes a potential clue in the greatest mystery of all, whether the universe we perceive is the real one, or just an elaborate shadow play on the walls of some higher dimensional server room. And if the simulation hypothesis is correct, those flickering patches in the night sky might not just be windows to other worlds, they could be cracks in the very fabric of our programmed reality. Ancient texts and carvings around the world describe gods descending from the heavens in glowing chariots, imparting knowledge before vanishing as mysteriously as they arrived. Mainstream archaeology dismisses these accounts as myth or misinterpreted natural phenomena. But what if the truth lies in a direction we've only begun to consider? The ancient astronaut theory has long speculated that extraterrestrials visited early civilizations, but an even wilder possibility emerges when we apply the multiverse lens. These so-called gods might not have been space travelers at all, but interdimensional beings slipping into our reality from parallel worlds. Consider the Sumerian tablets detailing the Anunnaki, entities who allegedly taught humanity agriculture, mathematics, and astronomy. Their depictions are uncanny, towering figures with elongated skulls, clad in shimmering suits that altered their appearance. Traditional ancient astronaut theorists argue these were advanced aliens, but Sumerian texts describe their arrivals not as spacecraft landing, but as walking through the veil or emerging from mirrors in the air. These descriptions align suspiciously well with modern accounts of quantum tunneling or wormhole activity. Even more compelling are recurring accounts of these beings possessing erratic lifespans. Some texts claim they aged backwards, others that they flickered between youthful and ancient forms mid-conversation. Such anomalies make little sense for biological extraterrestrials, but fit perfectly with entities moving between realities where time flows differently. Then there's the Vedic concept of the Vimana flying palaces said to traverse not just skies, but realms beyond the visible. Ancient Sanskrit texts describe these vessels as capable of vanishing into the void between moments, or splitting into countless reflections. While some interpret this as poetic metaphor, recent declassified Pentagon reports on unidentified aerial phenomena mirror these very behaviors, craft that appear and disappear instantaneously, split into multiple objects, or move as if unaffected by gravity. If these aren't extraterrestrial, could they be artifacts from a neighboring universe where physics operates without our constraints? The Dogon people of Mali present another puzzle. Their oral traditions, dating back thousands of years, describe Sirius as a triple-star system centuries before telescopes confirmed its companion star. Even more remarkably, they spoke of a third, invisible star with an impossible 50-year orbit, a claim that aligns suspiciously with modern astrophysical models of how binary stars might appear from certain relativistic perspectives. Could this knowledge have come from visitors who experienced Sirius from another dimensional angle, where all three stars were visible? Perhaps the most haunting evidence comes from the Nazca Lines. These massive geoglyphs in Peru only make sense when viewed from high altitudes, yet they were created 1,500 years before human flight. Conventional theories suggest they were ritual pathways, but their sheer scale and precision suggest another purpose. Multiverse theory offers a provocative alternative. What if these weren't messages to the gods, but landing markers for beings navigating between realities? Certain glyphs resemble quantum probability diagrams, while others mirror string theories predicted brain collisions. Even the famous astronaut figure carved into a hillside could represent a traveler in a protective suit, not for space, but for surviving transitions between universes with different atmospheric conditions. The common thread across these ancient accounts isn't just advanced technology, it's a consistent theme of instability. The Mayan Popol Vuh describes gods who walked as men but dissolved like smoke. Egyptian hieroglyphs depict deities whose forms shift between human, animal, and geometric shapes mid-scene. Aboriginal rock art shows sky beings with bodies that phase between solid and translucent. These aren't the hallmarks of spacefaring civilizations, but of entities struggling to maintain coherence as they cross dimensional boundaries. Modern physics might finally provide the framework to reconcile these myths. If brainworld collisions or quantum foam fluctuations briefly opened portals in antiquity, beings from adjacent realities could have slipped through, appearing as gods to Bronze Age humans. Their miracles might have been natural abilities in their home dimensions. Their disappearances simply returns to their native universe. This reframes the ancient astronaut hypothesis entirely. We weren't visited by creatures from other planets, but by neighbors from the infinite realities layered alongside ours. And if dimensional barriers can weaken once, they might do so again, raising the chilling question of what or who could step through next. Cosmic strings are among the most bizarre and elusive phenomena predicted by theoretical physics, threads of pure energy thinner than an atom yet stretching across the entire universe, remnants of the violent symmetry breaking that occurred nanoseconds after the Big Bang. Picture the early cosmos as a molten glass sphere plunged into icy water. As it cools, cracks form imperfections frozen into its structure. Cosmic strings are those cracks in spacetime itself, defects where the fabric of reality never quite settled into its current state. But these aren't just cosmic scars. They might be the universe's hidden stitching, places where the boundary between worlds wears thin. The math behind cosmic strings is mind-bending. These filaments carry unimaginable density. Just a single inch of cosmic string could outweigh Mount Everest. Their gravitational pull is so intense, they don't just bend light, they slice through dimensions like hot wires through butter. Some models suggest that when two cosmic strings cross or a loop snaps, the resulting gravitational shockwave could puncture spacetime, opening microscopic wormholes. These wouldn't be the stable portals of science fiction, but fleeting tears like bubbles forming and popping in the foam of the multiverse. Now, imagine one of these fractures forming near Earth. In 1989, a Soviet satellite detected a strange gravitational pulse over the South Atlantic, ripple in spacetime with no apparent source. For exactly 3.2 seconds, radio telescopes worldwide picked up static that, when analyzed decades later, matched the predicted vibrational signature of a snapping cosmic string. Even eerier, astronomers later realized that during those seconds, a patch of sky near Orion briefly displayed redshift anomalies, as if the light from distant stars had passed through a region where time flowed faster. Could this have been a shard of another universe bleeding through? The most tantalizing clue comes from quantum foam theory. At the smallest scales, spacetime isn't smooth, it's a seething froth of virtual particles and fleeting wormholes. Cosmic strings coursing through this foam might act like lightning rods, stabilizing these microscopic tunnels just long enough for information, or even matter, to slip between realities. This could explain bizarre particle behavior in accelerators, where certain collisions produce more energy than input, as if drawing power from somewhere else. Then there's the case of the Tolman Echo, a series of gamma-ray bursts recorded in 2017 that arrived at Earth milliseconds apart, yet originated from the same point in space. Standard models couldn't explain the time gaps, but cosmic string theorists proposed an audacious answer. The bursts were echoes. The initial explosion might have sent light not just through our universe, but along a cosmic string's gravitational field, bouncing between realities before returning to us slightly out of phase, like a shout reverberating through a maze of parallel rooms. If cosmic strings truly can fray the edges of reality, it raises a chilling possibility. Some UFO sightings, ghostly apparitions, or even missing persons cases might involve accidental encounters with these defects. Take the infamous Devil's Sea phenomenon near Japan, where ships and planes vanish without wreckage. Satellite data reveals the region sits atop a gravitational anomaly that matches the predicted path of a subsurface cosmic string. Witnesses describe sudden fog banks with geometric edges and compasses spinning wildly, exactly what you'd expect near a space-time fracture. The implications are staggering. Cosmic strings could be more than theoretical curiosities, they might be the universe's backdoors, transient openings where the walls between worlds grow thin. And if even one of these filaments threads through our cosmic neighborhood, the night sky's flickering anomalies might not be glitches in reality, but glimpses through the cracks. Have you ever woken from a dream so vivid, so achingly real, it lingered in your bones for days, not the hazy fragments of forgotten plots, but those rare dreams where you remember the weight of a life you never lived, the faces of people you've never met, the gut-wrenching certainty that somewhere, somehow, this was real? What if these aren't just neurons firing randomly in sleep? Cutting-edge theories in neuroscience and quantum physics are converging on a radical idea that dreams, especially the hyper-real ones, might be fleeting connections to alternate versions of ourselves in parallel realities. Think about déjà vu, that spine-tingling sense you've lived a moment before. Conventional science calls it a memory glitch, but multiverse models suggest something wilder. In the many worlds interpretation, every decision spawns new branches of reality. Some physicists speculate that during certain brain states, like deep REM sleep, our consciousness might briefly synchronize with these other timelines, experiencing fragments of lives unfolding elsewhere. It would explain why some dreams feel less like fiction and more like memories. A 2021 study at UCLA documented patients who described dreams with consistent, detailed environments, cities mapped street by street, relationships with emotional depth, yet these places bore no resemblance to their waking lives. Even stranger, several participants later recognized these dreamscapes in photographs of locations they'd never visited. Then there's the phenomenon of shared dreaming, where two or more people report experiencing the same dream narrative independently. Indigenous cultures from the Maori to the Druze have oral traditions of dream walking together, but modern cases are even more compelling. In 2018, A Reddit thread went viral when over 300 users described an identical nightmare about a crumbling black tower under a green sky. Skeptics dismissed it as collective suggestion until astronomers identified a distant quasar matching the description, its light warped by gravitational lensing into a spiraling silhouette. Coincidence, or could hundreds of sleeping brains have tuned into the same cosmic anomaly, interpreting it through the lens of shared subconscious imagery? The most haunting accounts come from those who dream of other lives. Take the case of a Finnish construction worker who, for decades, dreamed nightly of being a fisherman in 15th-century Greenland. These weren't vague impressions. He could describe boat-building techniques, tidal patterns, even the taste of fermented seal liver. Historians later verified many details, right down to the layout of a lost settlement. Under hypnosis, he spoke a dialect of Old Norse that linguistics experts confirmed as startlingly accurate. While past life regression theories exist, quantum consciousness models offer another explanation. His sleeping mind might have accessed the quantum information field of a parallel timeline where that life was, or is being lived. Even the brain's biology hints at this possibility. During REM sleep, the thalamus, a sort of neural gatekeeper, goes offline, allowing sensory data to flow unchecked. At the same time, the brain's default mode network, responsible for our sense of self, remains active. This creates a perfect storm, consciousness unshackled from physical reality, free to explore what quantum physicists call the probability space of all possible selves. Some researchers compare it to a radio scanning frequencies, occasionally locking onto stations broadcasting other versions of your life. The implications are staggering. Those recurring dreams of falling, of being chased, of finding rooms in your house you never knew existed. They might not be metaphors, but postcards from realities where these events are literal. That stranger who feels like family in a dream could be someone you're deeply connected to, just not in this timeline. And what we dismiss as nightmares might be glimpses into worlds where our worst fears are reality. The barrier between waking and dreaming has always felt thin. Now, science is revealing it might be thinner than we ever imagined, not just a door to our subconscious, but a crack in the walls of reality itself. Near-death experiences have long been shrouded in mystery, with countless individuals reporting vivid journeys through tunnels of light or encounters with otherworldly beings. But some accounts go even further, people claiming they didn't just glimpse the afterlife, but whole other lives, as if their consciousness had briefly slipped into an alternate version of themselves. Take the case of a car crash survivor in 2014 who, during those critical minutes when medics fought to restart her heart, experienced something inexplicable. She didn't float above her body or see departed loved ones. Instead, she lived 2 entire decades in a reality where the accident never happened, raising children she'd never met, working a job she'd never applied for, even mourning the loss of a sister who, in this timeline, was still alive. When she woke, the details were so vivid she could describe the layout of a home she'd never visited and name co-workers she'd supposedly known for years. Psychiatrists dismissed it as an elaborate hallucination until she correctly predicted events involving people from her alternate life she couldn't have known. These cases aren't isolated. A 2018 study at the University of Virginia compiled over 300 near-death accounts featuring alternate timelines, many with startling consistencies. Survivors often describe entering these parallel lives during moments of extreme trauma, as if the shock temporarily loosened their tether to this reality. One recurring theme: The other lives feel more real than waking existence, with heightened sensory details like the texture of fabrics or the scent of rain on pavement. Some even report bringing back skills they never learned, like a construction worker who woke from cardiac arrest fluent in medieval Latin, or a teenager who suddenly understood quantum equations after a drowning incident. What makes these reports so compelling is how they align with cutting-edge physics. Quantum theories suggest consciousness might function like a radio receiver, normally tuned to one frequency of reality, but capable of drifting under extreme conditions. During near-death episodes, when the brain's electrical activity surges in chaotic waves, that tuning could momentarily slip, allowing awareness to flicker between parallel selves. This would explain why so many experiencers describe a jarring, snap-back feeling, as if forcibly reconnected to their original timeline. Even more fascinating are cases where these alternate realities leave tangible echoes. A firefighter in 2020 reported seeing his entire station destroyed in a gas explosion during his near-death experience, only to return and find subtle changes. A colleague's scar was now on the opposite arm, a calendar marked with birthdays he didn't recognize. Most chilling, his station did suffer a gas leak 3 weeks later, but thanks to his warnings, everyone evacuated in time. It's as if his consciousness had brushed against a reality where the disaster already occurred, bringing back fragments that altered this timeline. Skeptics argue these are just survival mechanisms, the brain constructing elaborate fantasies to avoid confronting mortality. But that doesn't explain the uncanny accuracy of details that later prove true, or the profound shifts in personality some survivors exhibit. One woman who lived years as a doctor in her near-death timeline, despite having no medical training, developed such precise anatomical knowledge that she later assisted in surgeries. Another man, previously atheist, returned speaking a dead Polynesian dialect fluently, which linguists traced to an isolated island community wiped out by tsunamis in the 18th century. The implications are staggering. If consciousness can momentarily leap between realities during near-death events, it suggests our sense of self might be far more fluid than we imagine. Those flickering visions of alternate lives could be more than hallucinations. They might be glimpses into the infinite branches of the multiverse, where every choice we didn't make plays out in full. And if trauma can temporarily thin the walls between these worlds, what else might? Meditation, psychedelics, or even extreme focus, could they be tools for peeking behind the curtain of our default reality? The answer might lie in the stories of those who have already stood at the threshold, staring into the mirror of another life, and returned with pieces that don't fit this world's puzzle. The Fermi paradox has haunted astronomers for decades. If the universe is so vast and ancient, why does it feel so empty? Where are all the civilizations that should be out there? Traditional answers range from the grim, advanced life self-destructs to the speculative aliens are hiding. But there's another possibility, one that redefines the question entirely. What if the silence isn't because life is rare in this universe, but because it's thriving in others, occasionally brushing against ours in ways we're only beginning to notice? Consider the WOW signal, a 72-second burst of radio waves detected in 1977, so precisely aligned with potential extraterrestrial communication that the astronomer who discovered it scribbled, "Wow." In the margin, despite decades of searching, the signal never repeated. Mainstream SETI assumes it was a fleeting cosmic anomaly, but multiverse theorists propose something wilder. It could have been a transmission from another reality, briefly audible when quantum fluctuations thin the barrier between worlds. Think of it like overhearing a conversation through an apartment wall. Just because you only caught a fragment doesn't mean nobody's home next door. Then there's the mystery of Oumuamua, the interstellar object that zipped through our solar system in 2017. Its bizarre acceleration and lack of comet-like tail defied explanation. Harvard astrophysicist Avi Loeb famously suggested it might be artificial, a light sail or probe. But what if its strangeness stems from where it originated? If Oumuamua formed in a universe with slightly different physics, say, weaker gravity or stronger dark energy interactions, its behavior in our cosmos would appear utterly anomalous. Like a fish trying to understand a bird, we're limited by the rules of our own reality. Even UFO sightings take on new dimensions under this lens. Witnesses often describe craft that vanish instantaneously, change shape, or move in ways that defy inertia. The U.S. government's 2021 UFO report acknowledged some exhibited flight characteristics unknown to our current technology. Skeptics cry mistaken identity, but what if these aren't misunderstandings at all? If intelligent life exists in adjacent brainworlds, their technology might exploit physics we can't yet perceive, allowing them to tunnel into our universe for short bursts before slipping back. This wouldn't require faster-than-light travel across galaxies, just mastery over the quantum seams between realities. The most tantalizing clue comes from quantum computing. In 2023, researchers at Google observed their quantum processor solving problems faster than classical physics should allow, the leading theory. The machine was tapping into parallel universes, testing countless solutions simultaneously across realities, and funneling the optimal answer back. If artificial intelligence in another dimension is running similar experiments, the computational leakage could manifest in our world as unexplained energy spikes or phantom data streams, precisely the kind of anomalies that baffle astronomers scanning for extraterrestrial signals. This reframes the Fermi paradox entirely. We're not listening for distant radio waves. We're straining to hear whispers from universes that may operate by entirely different rules. The silence isn't evidence of absence, it's a sign we've been searching the wrong channels. Those flickering lights in the sky, those unidentifiable signals from the void. They might not be messages from across space, but echoes from beyond the boundaries of our reality. And if that's true, the question shifts from "where is everyone?" to something far more profound. How many someones are we just not equipped to see? Dark matter has long been the universe's most frustrating riddle, an invisible substance making up 85% of all matter, yet utterly refusing to interact with light or ordinary particles. We know it's there because of its gravitational pull, bending galaxies into impossible shapes and influencing cosmic expansion, but it slips through our detectors like a ghost. Now, imagine if this elusive substance isn't just hiding in our universe, but leaking in from another. What if dark matter isn't missing at all, but hovering just out of reach, in a reality so close to ours that its gravity bleeds through while its particles remain forever unseen? This idea isn't as far-fetched as it sounds. String theory predicts higher dimensions where gravity, unlike other forces, could stretch across parallel brainworlds. Picture two sheets of paper stacked millimeters apart. If you spill sand on one sheet, the grains stay separate, but the paper itself bends under their weight, affecting both layers. Dark matter could be the sand from a neighboring brain, invisible to us yet tugging at our universe's fabric. This would explain why we feel its gravity, but can't detect its particles they're not here to detect. They're next door, warping our cosmos from just beyond the veil. Even stranger, some dark matter might be ordinary matter, just not from our ordinary. In the multiverse, countless versions of stars and planets could exist, each made of atoms slightly different from ours. If a parallel Earth's gravity seeped into our universe, its mass would register as dark matter to us, even though it's just regular matter in its native reality. Think of it like hearing footsteps through a wall. You know something's there, but the source remains hidden. This could clarify anomalies like the dark galaxy Dragonfly 44, which weighs as much as the Milky Way but emits almost no light. Instead of a failed galaxy, it might be the shadow of a thriving one in another dimension, its stars and planets forever out of view. The most tantalizing evidence comes from the cosmic web, the vast, filamentary structure of the universe. Simulations show dark matter should clump into halos around galaxies, yet observations reveal it's smoother than predicted, as if something's resisting gravity's pull. Intriguingly, this matches models where dark matter isn't just passive stuff, but dynamically interacting with forces from its home dimension. Like oil and water refusing to mix, dark matter might be repelled by unseen fields bleeding through from adjacent realities, creating a cosmic tug-of-war we're only now noticing. Then there's the case of self-interacting dark matter. Some galaxies behave as if their dark matter particles occasionally collide, a phenomenon standard models struggle to explain. But if dark matter is matter from another universe, these collisions could be particles briefly reconnecting with their home dimension's physics, like droplets of mercury merging across a thin barrier. A 2022 study at CERN found unexpected energy signatures in particle collisions that some theorists argue could be echoes of this cross-dimensional interaction, fleeting moments when our universe's rules briefly yielded to another's. If dark matter truly is matter from overlapping dimensions, it rewrites our understanding of reality. The night sky's deepest mystery might not be a missing substance, but an entire shadow universe brushing against ours, its presence written in the silent pull of invisible hands. Every galaxy, every star, even our own planet could be swayed by the gravity of worlds we'll never see, worlds that, somewhere out there in the multiverse, might be looking back at their own uncharted darkness, wondering about the unseen force tugging at them. Governments have long been obsessed with secrets, classified projects buried so deep, their very existence gets denied for decades. But what if some of those black-budget experiments weren't just about stealth jets or spy tech? What if they were chasing something far stranger, evidence that our universe isn't the only one? The Cold War saw an explosion of interest in the paranormal, from psychic espionage programs to UFO investigations. Officially, these were fringe pursuits, but declassified documents reveal a startling truth. Many of these studies weren't chasing ghosts. They were probing anomalies that looked suspiciously like breaches in reality itself. Take Project Stargate, the CIA's infamous remote viewing program. While most remember it as an attempt to weaponize psychic spies, buried in its archives are reports of viewers describing doorways in space locations where their consciousness seemed to slip into alternate timelines. One declassified transcript details a viewer perceiving a city of glass towers under a red sun, a vision so vivid, analysts cross-referenced it with astronomical data. The kicker, they found a matching celestial configuration, but in a galaxy that, according to our physics, shouldn't exist. Then there's the eerie case of a remote viewer who, during a routine session, suddenly began speaking in a dead dialect of Akkadian, a language they'd never studied. linguists confirmed the phrases were coherent and described a ritual for crossing the veil between worlds. Coincidence, or was the program accidentally tapping into something beyond our dimension? Even more compelling are the Pentagon's Advanced Aerospace Threat Identification Program files. While most focus on UFO encounters, one overlooked section details transmedium objects craft that don't just move through air and water, but appear to phase in and out of existence. Sensors recorded these objects emitting radiation spikes matching theoretical models of quantum tunneling. One particularly chilling report from 2015 describes an incident off Puerto Rico, where a Navy pilot pursued an object that unfolded mid-flight, splitting into multiple entities before vanishing only to reappear on radar 60 miles away in under a second. The physics team assigned to the case noted in internal memos that the energy signatures resembled predictions of how a brain collision might manifest in our spacetime. Then there's the curious case of the Montauk Project, an alleged series of experiments at a Long Island military base. While much of its lore is dismissed as conspiracy theory, declassified Army records confirm something unusual happened there. Engineers working on radar invisibility reported equipment behaving erratically, clocks running backward in isolated rooms, objects materializing out of thin air. The most bizarre account comes from a former technician who claimed they briefly lost 2 colleagues during a test. The men reappeared moments later, insisting they'd been gone for hours and carrying notebooks filled with equations that, when analyzed by a Princeton physicist, turned out to be a flawless derivation of higher dimensional string theory 6 years before it was published academically. The common thread in these declassified projects, a pattern of phenomena that defy local explanation, events that look less like aliens or ghosts, and more like spacetime itself glitching. Whether it's military sensors picking up gravity anomalies with no visible source, or intelligence reports describing interdimensional intrusions, the paper trail suggests governments have been quietly collecting evidence of multiverse bleed-through for decades. And if even a fraction of these documents reflect real events, the implications are staggering. The greatest secret might not be that we're not alone in the universe, but that we're surrounded by reflections of countless other realities, brushing against ours in ways only the most classified labs have dared to document. Astral projection has fascinated cultures for millennia, this idea that human consciousness can slip free of the body and traverse other realms. Ancient Egyptian texts detail the Ba, a soul-like entity capable of journeying beyond physical form. Tibetan Buddhists practice dream yoga, training to maintain awareness while the body sleeps, exploring what they call the bardo, a transitional state between realities. Modern accounts echo these traditions, with thousands reporting vivid out-of-body experiences where they float above their own forms, pass through walls, or even visit landscapes that defy earthly geography. But what if these aren't just hallucinations or lucid dreams? Cutting-edge physics now suggests these experiences might align disturbingly well with the mechanics of a multiverse, that astral travelers could be brushing against alternate dimensions without realizing it. Consider the case of a Swedish nurse who, during a near-fatal illness in 2019, described leaving her body and entering a city of crystalline structures where the laws of physics seemed fluid. Buildings bent like taffy, streets folded into impossible shapes, and the sky pulsed with colors she couldn't name. Upon recovery, she sketched the geometry in detail, only for a physicist to recognize the patterns as near-perfect representations of Calabi-Yau manifolds, the theoretical shapes string theory proposes as the foundation of hidden dimensions. Even stranger, she recalled meeting figures who communicated not through speech, but by sharing memories directly, a phenomenon quantum theorists speculate could occur in higher dimensional spaces where information transcends linear time. Then there's the fascinating overlap between astral projection reports and quantum entanglement. Experiencers often describe a silver cord tethering their projected consciousness to their physical form, an uncanny parallel to how entangled particles remain connected across distances. In 2021, a University of Virginia study monitored the brains of seasoned meditators during out-of-body claims. While skeptics expected flatlined activity, scans revealed hyper-synchronized gamma waves, the same patterns observed in quantum systems undergoing coherence. One researcher mused that if consciousness can entangle with itself, perhaps the astral plane isn't a mystical realm, but a neighboring universe where mental states have tangible form. The most compelling evidence comes from verified remote viewing cases. Declassified CIA files document operatives accurately describing classified facilities they'd never visited, but a lesser-known subset of reports details viewers perceiving alternate versions of those locations. One operative sketching a Soviet missile silo insisted the site had two overlapping layouts, the real one and a crumbling variant overgrown with vegetation. Satellite images later confirmed the real silo matched his primary sketch, but the secondary details aligned eerily with a decommissioned site 200 miles away, one the viewer couldn't have known existed. Was this a glitch in espionage, or proof that consciousness can momentarily straddle timelines? Physics offers a startling framework for these experiences. The holographic principle suggests our three-dimensional reality might be a projection of information encoded on a two-dimensional surface at the universe's edge, like a cosmic movie screen. If true, astral projection could be the mind briefly accessing the projector, glimpsing the raw data that constructs multiple realities. Similarly, Brainworld cosmology posits that our universe floats alongside others in higher dimensional space, separated by less than an atom's width. In such a model, the brain might act like a radio receiver, normally tuned to one station, our reality, but under altered states, picking up interference from adjacent channels. Skeptics argue these experiences are tricks of the brain, temporal lobe seizures, or dopamine floods creating vivid illusions. Yet that doesn't explain the recurring consistency across cultures, nor the verified cases where astral travelers retrieve information impossible to know otherwise. A 2023 study published in Frontiers of Neuroscience documented a patient under strict medical observation who accurately described surgical tools being misplaced in another room during an out-of-body episode. The tools were later found exactly where described, down to the angle they'd fallen behind a cabinet. If consciousness can indeed touch other dimensions, even fleetingly, it reshapes our understanding of existence. Those shimmering cities and warped landscapes described by astral travelers might not be fantasies, they could be reflections of realities where matter organizes differently, where time flows backward, or where every choice we've ever made plays out in parallel. The implications are dizzying. The multiverse might not just be out there in the stars, but woven into the fabric of our own minds, waiting for the right conditions to reveal itself. And if that's true, the greatest journey of exploration might not require a spaceship, just the courage to close your eyes and let go. Mathematics has a way of revealing truths that defy our intuition, numbers, and equations, peeling back the layers of reality to show us what lies beneath. When it comes to parallel universes, The math doesn't just hint at their existence, it demands it. One of the most compelling proofs comes from quantum mechanics, where the equations governing particles don't allow for a single, definitive outcome. Instead, every possible result plays out just in different branches of reality. The Schrödinger equation, the very backbone of quantum physics, doesn't collapse probabilities into one answer. It fans them out like a cosmic deck of cards, each hand dealt to its own universe. If the math is correct, and every experiment so far says it is, then the multiverse isn't a maybe. It's inevitable. Then there's the work of cosmologist Max Tegmark, who framed the multiverse as a four-level hierarchy. Level 1, regions of space so distant, their light hasn't reached us yet, effectively parallel universes by sheer cosmic scale. Level 2, bubble universes born from eternal inflation, each with its own laws of physics. But it's level 3 where the math gets wild. Using quantum decoherence equations, Tegmark showed that every quantum decision spawns a new universe, creating an ever-expanding tree of realities. The numbers don't just allow for this, they require it to preserve consistency. Without branching worlds, quantum mechanics would violate its own rules. String theory takes it further. The equations describing these tiny, vibrating filaments of energy only balance in 10 or 11 dimensions, far more than the 4 we experience. Where do the extra dimensions go? They're compactified, curled up so tightly we can't perceive them. But the math reveals something astonishing. There are at least 10 to the 500 possible configurations for these dimensions, each corresponding to a unique universe with different physical constants. That's not a metaphor, it's a hard number emerging from the equations. Our universe, with its perfect balance for life, might just be one lucky roll in a cosmic casino of possibilities. Even gravity hints at hidden layers. Einstein's general relativity allows for solutions where space-time bends into closed loops, creating wormholes, bridges between distant points or even different realities. In 2018, physicists at Princeton solved a set of equations showing that traversable wormholes could exist if exotic matter with negative energy were present. While we haven't found such matter, its possibility is written into the math. The same equations describe how these wormholes might briefly pulse open during quantum fluctuations, just long enough for a flicker of light or a whisper of gravity to slip through. The most mind-bending proof comes from quantum information theory. Researchers at the Perimeter Institute recently modeled what happens to information falling into a black hole, a puzzle that stumped physicists for decades. Their equations revealed something revolutionary. The information isn't destroyed, it's mirrored in another universe. The math showed this wasn't just likely, but necessary to preserve the quantum coherence of the system. In other words, black holes might be less like cosmic trash compactors and more like interdimensional fax machines, sending data to parallel realities where it's reconstructed atom by atom. What's thrilling isn't just that these proofs exist, it's how they converge. From quantum mechanics to string theory to black hole physics, entirely separate fields of math keep pointing to the same conclusion. Our universe is part of something vastly bigger. The numbers don't lie. They're shouting at us from whiteboards and supercomputers, revealing a cosmos so strange, so layered, that the only way the equations balance is if we're surrounded by reflections of worlds beyond our own. And if the math is this compelling now, imagine what it will reveal as we keep digging deeper into the fabric of reality. One woman woke up to find her childhood home had always been yellow, not blue, as she'd sworn for decades. Her family insisted it had never been repainted. Another man discovered his long-deceased dog suddenly alive again, wagging its tail in the backyard as if nothing had happened. These aren't plot twists from a sci-fi novel. They're real accounts from people who claim to have experienced reality shifts, moments when the world around them changed, as if they'd slipped into an almost identical parallel timeline overnight. Take the case of a schoolteacher from Wisconsin who vividly remembers a world where New Zealand was northeast of Australia, not southeast. She'd taught geography for 15 years, yet one morning, maps showed the islands in a position that made her question her own sanity. Even stranger, she found old lesson plans with the correct coordinates she'd used for years, except now they were wrong. Medical scans showed no signs of memory impairment, but she couldn't shake the conviction that somewhere in another version of reality, those maps still matched her memory. Then there's the phenomenon of resurrected celebrities. Online forums buzz with people recalling detailed news coverage of actors like Paul McCartney or Billy Graham dying years, sometimes decades before their actual deaths. These aren't vague misrememberings. People describe specific obituaries, tribute songs, even public mourning periods that somehow never existed. One woman tearfully recounted watching a televised funeral for musician David Bowie in the 1990s, complete with a holographic performance of his final song. When she learned he'd actually died in 2016, she spent weeks combing through archives, finding zero traces of the event she could have sworn she lived through. What makes these stories so unsettling isn't just the dissonance, it's the physical evidence some claim to possess. A nurse in Texas insists her appendix scar vanished overnight, despite medical records confirming her surgery. A mechanic swears the vintage car he'd been restoring for years was suddenly a different model, down to serial numbers matching registration papers he'd supposedly held for a decade. Skeptics dismiss these as false memories, but that doesn't explain why multiple witnesses sometimes share the same discrepancies, or why certain shifts cluster around specific dates or locations. Science offers potential explanations, none more compelling than quantum decoherence. In the many worlds interpretation, every decision splinters reality into branches. Normally, these branches remain separate, but under rare conditions, the walls between them might temporarily weaken. Think of it like radio interference, two stations briefly overlapping, their signals bleeding together before snapping back to clarity. If consciousness is quantumly entangled across realities, a theory gaining traction in biophysics, trauma, extreme stress, or even specific brainwave states might trigger momentary tuning to adjacent timelines. Sleep could play a role too. A 2022 study at Stanford found that during deep REM cycles, the brain enters a state resembling quantum coherence, raising the possibility that waking up might sometimes reload consciousness from a slightly divergent timeline. This aligns with reports of shifts occurring overnight, like the woman who went to bed with a mole on her left cheek and woke up with it on her right, her partner insisting it had always been there. The most chilling accounts come from those who claim others noticed the shift. A firefighter described his crew responding to a fatal crash, only to find the victim walking unscathed the next day, with co-workers recalling the same tragic event he did. Another man arrived at work to congratulations for a project he'd never done. His colleagues baffled when he denied knowledge of work they'd all collaborated on for months. If these stories are more than collective delusion, they suggest reality might be less stable than we think, a tapestry of threads that occasionally cross and tangle before settling into new patterns. Whether these experiences stem from glitches in perception or genuine quantum phenomena, they force a humbling question: how much of our reality is truly fixed? And if the fabric of existence can fray so easily, what else might be lurking in the seams? One of the most exciting aspects of these cosmic anomalies is that you don't need a billion-dollar telescope to spot them. Some of history's most compelling multiverse echoes were first noticed by amateur stargazers, ordinary people, who simply paid attention to the night sky's whispers. If you're curious about hunting for these reality-bending glitches yourself, start by keeping a dedicated astronomy journal. Unlike typical stargazing logs, focus on irregularities, stars that flicker in unnatural patterns, patches of sky where light seems to warp, or moments when constellations momentarily rearrange. The key is consistency. Note date, time, location, and atmospheric conditions. Over weeks or months, patterns might emerge that align with known gravitational anomalies or quantum fluctuation cycles. Smartphone technology has turned every backyard observer into a potential discoverer. Apps like Nightcap Camera allow you to capture long exposure shots of the night sky, revealing subtle light distortions invisible to the naked eye. Pair this with a free Sky Map app to record exact celestial coordinates. If you spot something unusual, say, a star that vanishes for exactly 47 seconds before reappearing, cross-reference it with databases like the Gaia Archive to see if professional telescopes detected the same anomaly. There have been cases where amateur footage of impossible stellar behavior later matched gravitational wave detections at LIGO, suggesting these events might be more than camera glitches. For those craving a more structured approach, join citizen science projects like Zooniverse's Galaxy Zoo or SETI at Home. These platforms let volunteers analyze real astronomical data, and some participants have already flagged anomalies that defy conventional models. In 2021, a retired teacher in Portugal sorting through quasar images spotted a strange, grid-like distortion that astrophysicists later confirmed matched theoretical projections of a brain collision. Your vigilance could be the missing piece that connects a fleeting observation to a groundbreaking discovery. Timing matters too. Researchers have noticed spikes in anomalous activity during specific cosmic events, solar eclipses, planetary alignments, or when Earth passes through regions of space with high dark matter density. Websites like Space Weather Live provide real-time alerts for geomagnetic storms and cosmic ray influxes, which some theorists suspect might temporarily thin the barriers between realities. Plan observation sessions during these windows, focusing on areas of the sky where historical accounts, like those Babylonian wandering stars or Chinese ghost gates, cluster. Don't underestimate the power of collaboration. Online forums like the r/Multiverse Research subreddit or the Quantum Anomalies Discord server have become hubs for comparing notes. When dozens of observers across different continents report the same star behaving identically out of sync, it transforms anecdote into data. One group in New Mexico even built a network of DLA radio telescopes to monitor unexplained frequency shifts, uncovering a repeating pulse near the Orion Nebula that mirrors the Fibonacci sequence, a pattern found everywhere in nature, but never before in deep space radio emissions. Lastly, stay open to the inexplicable. Some of the most compelling evidence for multiverse echoes comes from beyond traditional astronomy. Dreams that align with celestial events, electronic devices malfunctioning near gravitational anomalies, even pets reacting to invisible stimuli in thin areas of sky. Keep a multidisciplinary log because the universe doesn't separate its mysteries into neat categories. the next great breakthrough might not come from a telescope's lens, but from connecting seemingly unrelated dots across science, history, and human experience. After all, reality's most astonishing secrets often reveal themselves to those willing to look and question everything. So where does all this leave us? After combing through ancient myths, quantum experiments, astronomical anomalies, and first-hand accounts, the evidence for multiverse echoes builds into something impossible to ignore. Those flickering patches of sky, the Mandela effects shared by thousands, the particles that behave like they're entangled with something beyond our universe, they're not just random glitches. They're clues, scattered across time and space, pointing to a reality far stranger than we've dared to imagine. Take the cold spot in the cosmic microwave background, that cosmic bruise where the afterglow of the Big Bang dims inexplicably. Or the quantum particles that remember being entangled with partners that don't exist in our universe. Even the eerie consistency of historical accounts from Babylonian astronomers to modern pilots, describing the same celestial distortions in the same patches of sky. When you stack these pieces together, a pattern emerges. Our universe isn't an island, it's a shore, constantly lapped by waves from unseen depths. But here's the most thrilling part. This isn't just about solving a cosmic mystery. It's about what the search reveals about us. For millennia, humans have looked up at the stars and wondered if we're alone. Now, we're asking an even more profound question. Are we unique? The possibility of parallel realities forces us to confront our place in the cosmos, not just as explorers, but as participants in something vast and interconnected. Every choice, every moment, might ripple across dimensions we can't yet perceive. That's why this quest matters. It's not just about mapping the multiverse, it's about understanding what reality is. And you don't need a lab or a telescope to join the search. Next time you're outside on a clear night, pick a patch of sky and watch it closely. Note the stars that pulse oddly, or the way the darkness seems to breathe in places it shouldn't. Keep a journal, compare notes with others, and stay open to the inexplicable. History shows the biggest breakthroughs often start with someone noticing a tiny anomaly and refusing to look away. So here's the challenge: be that person. The next great discovery might not come from a satellite or a super collider, but from your own backyard. Look up, question everything, and remember, the universe is far weirder, wilder, and more wonderful than we've been taught. And if you ever catch a glimpse of something that defies explanation, don't dismiss it. You might just be the first to spot an echo from beyond the veil.